Hey everyone, Ale here. Wanted to follow up with a video now showing the event management that we have in Vortex. This is work that came in recently, and it allows detecting events, sending them down to the engine, which in time sends it down to scripts. So what we wanted to do to show everything working together in terms of a script receiving an event and running a simulation while directing the engine to alter its entities was, hey, let's just build a quick implementation of the Pong game. So let me show it to you real quick. It's gonna be hard to actually show it and talk at the same time, but here we go. So as you can see, I'm controlling these two paddles using the keyboard, and what we do is all of this is being handled by a script that has on start pre-registered to receive events, and these events are then sent to it by the engine automatically, and we just respond to them. As you can see on the lower left section of the screen, we actually print from the script as well. Whenever a player scores, that triggers an event where we just reset the simulation. In the future, we could have some UI showing the score, but the point was just to show events being passed. As you guys can see, we still have our deferred rendering going on. You can see 3 real-time lights, 2 are attached to the paddles, the other one is attached to the ball, and we can see how it's in real time altering what our level looks like. And yeah, I really like this example. It really shows, again, a lot of things going on. But what I want to do is stop this and actually show you in terms of the code how this was built. So here we can see the scene was just assembled in the engine directly. I got some textures that I'm gonna link in the description below. But yeah, let me just go ahead and show you the code. So as you know, Vortex Engine can be scripted from Lua. And it's not a lot of code. It's actually about less than 200 lines, and we have a complete implementation of the Pong game. So that's really a testament to how cool Lua is. Definitely recommend you embed it in your engine if you're thinking about options for scripting. Let me just show you real quick. So we have like a very quick math or vector library here, just because we're still not pushing this or publishing this in the engine API, but we will add it at some point. So for now, we just need to make do with this a little bit. It's just some simple vector math implemented in Lua. And these are the there's 3 main functions that are actually driving the entire simulation. First one, as you know, we start from our main function. This one is responsible for finding the entities that we're interested in. In particular, we want to find and define which one is the main camera for our engine or for our scene. This will make it so that we position the camera correctly in front of the game, and it would also make it so that the engine will send events to us. These 2 functions in particular, if you've been following my blog, you know what they are. The on-frame event is called every single frame, so this is where we want to implement our simulation. And our on-event function is a new one that we have this week, and will actually send us events whenever something happens, with a keyword in particular in this case. The rest of the code is just finding everything we're interested in. So we're interested in finding the left paddle, the right paddle, getting the transforms and caching them. We also want to get the world, so we know where things are around us, so we can calculate the physics. And let me just jump straight to those. Of course, we also need to get the lights, and we keep them in sync with all the animation going on. And this is pretty simple. Just get the transforms, and as we update the positions of things, we also make sure that the lights are kept in sync. This is the update function, but let me go first to on event. As you can see, it's very simple, classic implementation where we have essentially a table that records what keys are pressed and released. We just record what keys are active, and then in our update loop we just keep on doing the animation. I find this produces a very smooth animation as compared to having to deal directly with auto repeat events coming from the operating system. it's gonna be hard to get in details of the on-frame function in here, but let me just touch on the most important things. So as usual, we get the time that has elapsed since the last time we ran the simulation. Again, this is running at a fixed step in the engine so that we don't have any funny business going on, like if we skip some frames, the ball going through a wall, that cannot happen right now. And essentially we're trying to find intersections, or let's say collisions, of the ball with the walls and with the paddle. If we hit the floor or the ceiling, we just mirror the velocity for the ball, and that makes it bounce. If we hit, on the other hand, like the end of the either end, left or right, we will just check, okay, is the paddle around the same height? If it is, we just bounce the ball in the other direction. If it isn't, then we reset the simulation and we print a message saying, oh, okay, whatever player just scored, and yeah, that's just a point for that player. Then we have some logic here. Update paddles in particular ties in together with what we recorded on our onEvent function. So in particular, look, we are looking at the press keys, and if the key is indeed pressed this moment, we simply take into account the paddle speed, how much time has elapsed, and we update the position of the paddle based on that. So yeah, this is everything. I think it really shows that in under 200 lines of code, we can have a complete implementation of Pong, and this is, again, very happy with this, because if we were just writing this engine, let's say in a vacuum, and we wanted to test this, we would be writing this logic maybe in C++, and then you have to take considerations that your C++ code is not completely bound. You don't want to have game code inside your engine code, so being able to run your simulation in Lua and clearly marks a separation of concerns between what is engine and what is game, right? So yeah, that's everything I got for today. I'm gonna post this video on my blog and add some more information there in case you're interested. I'll probably put a copy of this Lua code in case you want to go through it. Make sure to leave me some comments, or if you have any questions, free to answer as much as I can. And yeah, I'll link the textures that I used down below, okay? Thanks for watching. See you in the next one.